Previously, I had introduced an atomic theory based on observations I made in BFDI 15 and 16. However, it doesn't include atomic bonding. In this video, I will introduce a more complete theory. My theory explains why atoms exist, the merge of the two atoms that we see in BFDI 5, and some other unseen behavior, like bonding, which is a property that we usually expect from atoms. In BFDI 5, we see two atoms, each one with one red and gray particle in the center and a blue particle in a shell. Each particle applies a force on the other particles. This force depends on the distance of the two particles and their charge. However, unlike the real world, the charge can't be represented as a real number. Each particle has its own charge that determines what particles it attracts or repels. We can make a table that says if a pair of two particles is attracted, repelled, or if there is no force. In BFDI 15, we see that there isn't a force between two individual red particles, so let's put a 0 on the table. Back to BFDI 5, we see that the red particle is next to the gray particle in the atom, so there is likely an attractive force between them. We also see that the blue particles are attached to the shell, so there is an attractive force between blue particles and shells. However, in my theory, a shell's charge isn't distributed uniformly throughout the entire shell. Instead, it is concentrated on what I call shell attraction points or saps. The blue particles are attracted to these saps. Let's add this to the table. Since the blue particles and shells are close to the nucleus, there is an attractive force between either the blue particles or the saps to either the red or gray particles, and the net force between all those particles has to be attractive on the atoms that we see in the show. So I'm writing a note explaining this on the table. Since unfilled saps attract blue particles, if an atom has unfilled saps, they will attract electrons from nearby atoms, and they will be stuck together with one electron filling both saps. This is called bonding. Note that only one blue particle can be shared like this in each pair of atoms. Since the atoms we see in the show don't bond with each other, they don't have unfilled saps. If atoms have enough kinetic energy when they get into contact with each other, they can merge. The number of red, gray, and blue particles and saps stay the same, but the shells of the two atoms get merged into one. It also would be useful to have a system to name these atoms. We could give them names, but they wouldn't give us information about the atom. So in my system, the name of the atom is composed of numbers. The first two numbers are the number of red and gray particles respectively, separated by a hyphen. Then there are two numbers for each shell, the number of filled and unfilled saps, which are grouped between parentheses and separated by hyphens. The groups are also separated by hyphens. So the atoms at the start of BFDI 5 are 1110. But there is one scene that I still need to talk about. In BFDI 15, Coyne, Pencil, and Fries remove red particles from some atoms, and when they do that, the number of blue particles also changes. I don't really know how to explain this, but here is my attempt. When a proton gets removed, there is a hole in the nucleus, and since protons and neutrons are attracted to each other, they want to fill the hole to get closer to more particles. But they get a lot of speed, and when they collide with other particles, that energy is released and an electron and sap get removed from the atom. I think this theory explains everything we see related to atoms in BFDI, and also has other properties that may be useful, although my explanation of why the blue particles disappear from the atoms in BFDI 15 is a bit hand wavy. This is all I have for this video. Goodbye.